should be a quick video, it never is, about an oddball cartridge I found on the internet. Yes, I go off on large bore, weird, and usually non-lethal. Aircraft Armaments Incorporated 1965 Model L-110 tear gas and grenade launcher utilized its AAI Model C-100 12-gauge blank cartridge. It was a two-piece casing with a burst can or cup that was deep crimped over a brass-rimmed base wad as a plug that went into it. Because it was made out of only two parts, but they required vastly different ways of being made, they were probably made at different companies. I should also point out I did another video on one of my channels about a flare cartridge that was built suspiciously in a very similar way, only instead of the burst can or cup, it was actually not meant to be burst, and it was made out of aluminum or some other metal like zinc, and that was the flare cartridge. And it had a similar thing where the base looked a lot like this. Now, while this will look like a semi-rimmed or rimless cartridge appropriate for, let's say, a pistol, just like the flare cartridge was, this one is actually not. It is a fully 12-gauge based thing. But the crimp it uses is at the base instead of the mouth, because it doesn't want to shoot what would be basically the outer casing out of the gun. Let's watch. First of all, this is the advertisement copy for it. The launcher cartridge shown at the left. Why does everybody do that? Showing it at the left when it's on the right. Contains smokeless powder. That's the difference. This is not a black powder cartridge. It produces enough energy to propel a multi-purpose grenade up to 120 yards. That's a long distance. So that means this thing had a lot of pep. Now, the size of the cartridge compared to the gun, obviously it looks pretty tiny. This is apparently the launcher. It's obviously more like a cannon these days. But this used a lot of space that could have contained a pretty good amount of propellant. And from the couple of pictures from some of the web boards I'm going to indicate that you can link to, it shows that it would split and sometimes screw up, but it was designed to make sure that you could extract it even from a pump-action shotgun, which makes this kind of an interesting cartridge. And yes, it's only one notch away from becoming capable of being used in a magazine-fed handgun, because it's short enough that you could wrap your entire hand around a shell with it pointing forward. That makes it capable of being used for, let's say, I don't know, how about a self-defense only handgun? I should point out I recently covered a flare gun that was based on literally it being basically a magazine with a trigger on it, and it would fire most of the front of the cartridge away. And as you can hear me leading to it, the base of this thing is here, and this is the part that, if it was a flare cartridge, would fly off and you'd end up with basically a washer, two different diameters to it. That would be the flare cartridge. This is the kind I think they might have used a similar patent from, because this came out before that flare cartridge. Now, obviously, it's not being used that way. This is a blank. And again, the next version of this cartridge ended up having an ordinary shotgun shell used because it's cheaper. Also for various other reasons. We'll review shotgun shell engineering in a minute, but let's get on with it. These are the dimensions for it. Everybody knows I'm going to look this up if I can find it. And you can see that this looks really weird. Now, this 0.8 inch or 0.79 inch, depending on how long it is, this one could be 0.8 inch because it's about an inch tall. This is like a high brass cartridge that cuts off right where the plastic would start, that kind of thing. Blanks are made this way. I have a bag somewhere in storage with a couple of them like this length. Yes, I have blanks. But anyway, and here we have a rim that's about the same as a shotgun shell. It would chamber correctly and may have been intended for some special purpose propelled piece of equipment, but they just ended up using it in shotguns that could tolerate short shells. And this here is where you see the difference. There's a 0.14 inch wide groove that goes from 0.8 inches down to 0.723. That's a pretty extreme change. Now I'm going to describe the engineering for it, but doing that, if it's brass, would work harden this part, and this part here may not have any effect. Let's move on. This is the head stamp that they used, AAI C-100. The C-200 was simply a 12-gauge shotgun shell, a short one. Right. And this is what it looked like from the side. That's pretty significant dent there. And I'll show you the way it was built, but basically this is an extruded piece of brass of a different grade than this. This is more of actual firearms or munitions brass here for the base. And this looks like a different grade of brass. I don't know what kind, but it would have to have been pretty malleable. And at the end of the process, this whole thing would have to be either extremely brittle on purpose or extremely soft. It couldn't be in the middle anywhere. So they would have had to anneal this or harden it on purpose. Hardening it may be advantageous because it's using smokeless powder. You see, it's not gunpowder, it's smokeless powder. That means there's possibly a really hefty charge in there. And this is the crimp that holds the whole thing together, unlike a crimp at the top like you'd see when it was firing a projectile. This is the raw components before the factory would do the crimp. Someone got at least one. This photo is from a web board. Now we can see very different methodologies here. First of all, this is spun. This is milled from a piece of metal, probably this diameter, milled and faced, then they drill in the hole, then they would grind this down to this diameter here, and then before they cut this off, they would cut a groove in here with a gouge. These are not indicative of a gouge. It looks more like it was done by milling it by using a rotary device that would grind in, and then they would just rotate it on axis and get some nice chips rather than having to run it on, let's say, a lathe. And then, of course, cutting it off. There's no pictures of the opening on this side, but this would represent the rim and base wad of a shotgun shell. Some of you may not know this, but when a shotgun shell is built, there's usually, not always, but usually a base wad that comes up to the height, approximately the height of what the shotgun primer would take up. Sometimes it's a waist, sometimes it isn't, but it strengthens it. And then a rim here would be a thin piece of metal that would wrap around the base wad and pinch between this and the outer layer of what would be the rim, which was normally a thin sheet of metal. There would be the actual wall of the shotgun shell, which is a simple tube, at least in the old days. It could be paper, plastic, or even sheet steel or aluminum brass. And then the end would be left open to fill it. This thing is done totally different. This piece here is formed by forming cups out of sheet metal. And in the process, it's going to work harden mostly the sides, which isn't a bad thing. And it would leave the end of it mostly softened. There are scoring marks in here that are stamped right at the last stage before the thing's popped off the assembly line. These are totally different methods for making it. This thing is milled and made on a machine, probably a lathe. This is probably bullet brass material remelted. And this one here could be the same metal, but it doesn't look like it. And it is obviously pressed and extruded from a sheet. That's what the end looks like with a scoring, and it gives you a perspective, extreme close-up of it. And that's what it looks like when you look at the grooves in it. That was stamped probably by a hardened piece of steel specifically made for the purpose, and this isn't a mistake. It was deliberately made slightly offset so each of these pieces would not have a straight line to line up with the other, which means it would be forced to burst in this area here with the thinnest part in it and then progress outward so that the gases would escape from it firing off or igniting the smokeless powder. So again, that's been the Aircraft Armaments Incorporated 1965 era, actually earlier, AAI Model C-100 blank for 12 gauge. And obviously, if it didn't have that crimp done to it, and if it never had that groove put into it for the crimp to work, this would make a pretty good knockoff of the flare cartridge I covered recently. And it's quite interesting, but really it's just a 12 gauge compatible blank. These days we use ordinary shotgun shells, and even they switched over to just using short shotgun shells. But it does bring up some interesting ideas. Now, again, if it isn't in a tightly fitted chamber in a shotgun, the pressure would probably release down here. So that's why they put a deep crimp in it, to make that very hard to have it happen. The idea was to make it to where the metal was weaker up here than this crimp could be, so it could propel something downrange. Well, that's it for today. Thanks for watching. Have a good day. Good luck with that. This was just about some weird cartridge I found. And yeah, I'm going to keep looking up weird stuff. Bye.